6-2 Trigonometry of right triangles. So you probably remember from algebra or from geometry having a right triangle, and when we looked at the angle in the corner, we could call the sides different things. So one side was opposite that angle, that was across from the triangle. Another side was adjacent, which was next to, and then we had the hypotenuse, which is always the longest side directly across from the 90 degrees. So using this, you probably remember the phrase SOHCAHTOA. That's usually how most people remember it, and that stands for sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. And all these are our trig ratios. They're going to tell us the ratio between the sides. Now, we also have three other trigonometric ratios, and these three ratios are the inverses. If you notice, it's just the reciprocal. So the reciprocal of sine is cosecant. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So we have sine, cosine, tangent, and these abbreviations are really just to shorten them up. Cosecant, secant, and cotangent. Okay, so all they are just the reciprocal. It's just flipped over. So instead, cosecant is hypotenuse over opposite. It's just the flip of sine. Cosine and secant, you just flip one over to get the other, and same with tangent. So for this triangle, in example 1, we want to find the 6 trig ratios of the angle. We don't need to know the angle. We're just getting the ratio of the sides. So we'll start with the easy ones, sine, cosine, and tangent. All right, well, this is opposite over hypotenuse, so here's my angle. This is the opposite side, this is the adjacent, and the hypotenuse is directly across from the 90 degrees. So opposite over hypotenuse is 2/3. Cosine is going to be adjacent over hypotenuse, so that's root 5 over 3. And tangent is opposite over adjacent, so that's 2 over root 5, but we really should rationalize this. So we'll multiply by root 5 over root 5, and that's going to really give us 2 square root of 5 over 5. And we really want to make sure we are rationalizing each time. All right, then we need to get cosecant, secant, and cotangent. And to get those, all we're going to do is take the reciprocal. So the reciprocal of 2/3 is 3/2. The reciprocal of root 5 over 3 is 3 over root 5. Again, we should rationalize this. So we'll multiply by root 5 over root 5, and that's going to give us 3 root 5 over 5. And then again, we'll flip this. Now, what I find to be easier is if we had to rationalize, go back to the spot before you rationalized it and flip that. It's going to save you a little bit of work. If cosine is equal to 3/4, we want to sketch a right triangle with an acute angle, theta, and find the other 5 trig ratios. All right, well, let's draw our triangle. It doesn't have to be to scale. We'll call one of the angles theta. It really doesn't matter which one. And if it's cosine, remember that is adjacent over hypotenuse. So the adjacent side would be down here. That's going to be 3. The hypotenuse is 4. And that makes this the opposite side. And we need to find that in order to finish this. All right, well, we know sine. Well, we don't know sine, but we know cosine is 3/4. We'll need tangent, and then we'll need cosecant. Secant we can actually get without doing any work. We'll just flip it over. And we'll need cotangent. All right, so to find that third side, what we can do is just, well, Pythagorean theorem. A squared plus b squared is equal to c squared. So that's 3 squared plus something squared, we don't know what it is, plus 4 squared. All right, so that's 9 plus something squared is equal to 16. 16 minus 9 is going to be 7. So that missing side is the square root of 7. We don't have to worry about plus or minus here because we're talking about the leg of a triangle. So our opposite side is root 7. That means sine is root 7 over 4. And when we flip, that's 4 over root 7, but we need to rationalize. So that's 4 root 7 over 7. And then tangent, we will do opposite over adjacent, so root 7 over 3, and cotangent, flip it over. Again, we need to rationalize, so we'll get 3 root 7 over 7. All right. going to talk about our special right triangles. Let me discuss this a little bit in class, but remember that if this is, well, we want to think of these as having a 1 here, and that makes it a little bit trickier. But if we look back at our unit circle, this was root 2 over 2, really because I divided by 1. And with the 30, 60, 90, we had the 1/2, and we had root 3 over 2. Okay. All right, whoops. So in radian, if you remember from the unit circle, 30 degrees was equivalent to pi over 6, 45 was pi over 4, and 60 was pi over 3. And I like to remember this, that the 3 and the 6 just kind of switch, and the one with the 4 has a 4. All right, so if I want to find the sine, the cosine, and the tangent of these measurements, what I can do is really go back to my triangles. So if I want to find the sine of 30 degrees, that would be the opposite side. This would be the hypotenuse. So that would be 1/2 over 1, or just 1/2. If I wanted to find the cosine, it would be the adjacent over the hypotenuse, root 3 over 2 over 1, which is just root 3 over 2. And if I wanted to find tangent, it would be opposite over adjacent. So that would be 1/2 over root 3 over 2. If I keep change flip, that's 1/2 times 2 over root 3. That's going to give us 1 over root 3, or root 3 over 3. And we know for cosecant, secant, and cotangent, we just flip them over. So that's 2 root 3 over 3, and that's just the square root of 3. Now we could do the same for pi over 4. So opposite over hypotenuse is going to be root 2 over 2. Same over here. And tangents opposite over adjacent, so that's going to give us 1. Again, when we just flip them over to get these answers, they're pretty simple. Now the 60 degrees, again, we can get that just switching these guys, which one is which. So the opposite and the adjacent are now switched. So now this is opposite 60 degrees, this is adjacent. So the opposite is root 3 over 2 over 1, or just root 3 over 2. Adjacent is 1/2 over the hypotenuse is just 1, so just 1/2. All right, and then we'll have root 3 over 2 over 1/2, so that's going to give us root 3. And then I can just keep going, flip things over. I'm going to get 2 root 3 over 3, 2, and root 3 over 3. And there's a lot of little patterns that you'll start to notice here. You'll notice for 45 degrees, sine and cosine are the same, which means cosecant and secant are the same, and your cotangent and your tangent are the same. Okay. You'll notice for 30 degrees that sine is the same as cosine of 60 degrees. You'll notice that root 3 over 2, that's cosine of 30, is the same as sine of 60. Okay. You'll also see that the tangent of 30 is the same as tangent or cotangent of 60. You'll find that, another color here, tangent of 60 and cotangent of 30 are the same. And then we have similar with cosecant and secant of 30 and 60, and with secant of 30 and cosecant of 60. These numbers seem to just repeat. All right, so what if we aren't using a special angle? Well, what we can do is actually use our graphing calculator to help us here. We have sine, cosine, and tangent buttons on our calculator. They're just a row above the numbers, 2 rows above the numbers, right? We see the sine, cosine, and tangent in the middle. And to find those, it's very simple. We just need to make sure we're in the correct mode. Now, if we need to find cosecant, secant, and cotangent, they're just the reciprocals. So we're just going to do 1 over sine, 1 over cosine, and 1 over tangent, and that will flip it over for us. So let's just see real quick what that looks like. All right, so we're going to make sure in our mode that we're in degree mode. If you're not, you're going to want to change it, okay? And we wanted sine of 20, cosine of 20, tangent of 20, okay? And then from there, we're going to do 1 divided by sine of 20, 1 divided by cosine of 20, and 1 divided by tan of 20, and all of those are going to give us our 6 trig functions. Oops. Okay. So we can also apply trig to some problems which you've probably seen in geometry. So one of the things we like to do is to solve a triangle. That means to find all of its parts. You're going to want to know all of the angles, measure of angle B, or A, B, and C. And you're going to want to know all of the sides. So lowercase a, lowercase b, and lowercase c. And actually some of this information is given to us. If you remember from geometry, across from capital A is lowercase a, across from capital B is lowercase b, across from capital C is lowercase c. So I have 12 for lowercase c, A is 30 degrees, C is 90, and if we know that this triangle has to add to 180, that makes 60 degrees the only leftover option. Okay, so we can actually, we could use our trig functions, but we could also go through and, remember what a 30, 60, 90 triangle does. But we could use our trig function as well to help us if we needed to. However, again, like I said, this is a 30, 60, 90 triangle. So across from 30, that's going to be 6 over here, and this is going to be 6 root 3. Okay, so we have 6, and we have 6 root 3. What I could do, though, if I needed to, was say that the sine of 30 degrees was equal to A over 12, and that the cosine of 30 degrees was equal to B over 12, and I could solve these problems to get those same answers. So I could multiply by 12 on both sides. A would be 12 times sine of 30, and I could use my calculator to get that answer. I'm going to get 6. And for B, it'd be 12 times the cosine of 30. This time I would get an irrational number, but it would be equivalent to 6 square root of 3. All right, and then there's one more thing we're going to talk about. That's your angle of elevation and depression. So your angle of elevation is from the horizontal up. You're usually looking up at something. And the angle of depression is from the horizontal down. And these really are alternate interior angles. So if we have a person and they are looking up at something, or if we have, maybe it's another person looking down at them, so their angle of depression looking down is really the same angle as that person's looking up. So they're alternate interior angles, right? These are both horizontal. They're alternate interior angles. So the angle of elevation should be congruent or equal to the angle of depression. So you'll be able to kind of mess with your triangles to make these problems work a little easier. All right, so it says that a giant redwood tree, I like to draw pictures for these, though I'm not very talented. A giant redwood tree casts a shadow of 532 feet long. Find the height of the tree. All right, that's what we want, is h. If the angle of elevation of the sun, meaning the sun is going to shine down, oops, that's terrible sun, and create that shadow. So the angle of elevation of the sun is going to be 25.7, that's in here, degrees. Okay, so this is the opposite side. This is the adjacent. That means this is a tangent problem. So we have the tangent of 25.7 degrees, and that's going to equal h over 532. Multiply by 532. And again, just going to use that calculator. So you'd say 532 times tan of 25.7. Just make sure you're in degree mode. So your height is going to be 338.9 feet long or tall.